Streaming. I was sort of hesitant about going live tonight because I'm like really tired. But I figured that I needed to get this done and I need to push myself to do this because it's important. This is a very important thing to get done. I'm gonna turn down the soundtrack a little bit. The music, by the way, is satisfactory. Just a satisfactory soundtrack. It's pretty good. I like it. Yeah, so I think that's about it. Let me just go ahead and epically post the link. Alright, there we go. I just pissed off a bunch of people by pinging them all in the Discord. Alright, I think that's about it. So yeah, today we're going to be working on making the enemies in Throw Everything smarter. That is about all the introduction I need to do, other than the fact that Throw Everything is a game where you can throw every item, it's a roguelike, and you have one life and you die. And you need to see how far you can get. So that's pretty much about it. I'm going to go to my organization and see all of the information that I need to see about what each of the enemies needs to be good at. Because we need to figure out, like... Because I know that my designer did a little bit of documentation about how generally the enemies should behave. Yeah, it's this right here. So, bandits just rush the player and try to stab them. That's fair. But they need to... I think we're going to start with bandits. The biggest thing is that the enemies, like, group up and kind of don't really, well, basically the enemies right now, they group up and they don't really, like, how do I put this? They just bunch up and stack on top of each other, and they don't give each other personal space, which obviously doesn't make any sense. Like, if you're an actual, like, group of bandits and you're trying to, like, shank a guy, you're not going to be all huddled up 2 millimeters away from each other. So that's like the biggest behavior that I need to implement, is just making things stay away from each other. And the idea that I had for actually getting that to work, let me get the live chat open. The idea that I had for getting that to work, let me pop this out. There we go. That should work. Awesome. All right. So the idea that I had was a matter of Boyd. This kind of stuff. So let's watch a little bit of this video and try and get an idea of what we're trying to do.
I like to play around with some Boyds. This rather strange term is what Craig Reynolds uses to describe bird-like objects in his paper on flocks, herds, and schools. So once I'd read through that, I created some little flying triangles to represent these creatures. To do anything interesting, though, they were going to need an awareness of their...
So, an interesting thing that I'm noticing here is that they have, like, a preferred, like, direction that they want to go.
surroundings.
Which is obviously something we want to. And, I mean, a lot of this is premeditated. I haven't just been thinking about this whole live stream, but I need to, like, get all my thoughts together so I can start.
So, I'll highlight one of them to be our subject of study. This Boyd should be able to sense the others inside this circle, which is...
Okay, so that's requirement number 1. We need to have a system for the enemies to be able to know where each other are. We can probably just do this through collisions. That's what I'm probably going to end up going with.
Its radius of vision. We can also define a view angle so that it can't see directly behind itself. Now, the paper describes 3 rules that determine the behavior of each Boyd.
I don't know about seeing behind itself. I don't know if that's relevant for us. Probably not.
Rule number 1 is to steer away from any nearby Boyds to hopefully avoid crashing into them. So with this rule enabled, you can see them fairly successfully dodging and swerving to avoid one another. Next, rule number 2 tells them to steer to move in the same direction as nearby voids. This alignment also helps them to avoid bumping into one another, and of course makes them behave more like an actual flock of birds. Finally, rule number 3. This rule is to steer towards the center of any nearby voids. By itself, this can cause them to form little swirling patterns, but let me now add the other rules back in. Suddenly, the voids are trying to not crash into one another, while also simultaneously trying to align directions and sort of jostle for position at the center of their flockmates.
So the overall idea here is that we want to basically give them behaviors and apply those behaviors over time, which I already tried to do something like this, but I failed miserably. So what I want to try and do is I want to implement some of the behaviors and then have like a target that they're supposed to go to, and then just see how well they can like, because when I say they, I mean like I'm just going to make like some agents, because I don't want to do pathfinding, because pathfinding is expensive, and the problem with like A-Star is that I would have to make like the problem with doing pathfinding is that the area is procedurally generated, so we would have to generate the pathfinding mesh at runtime, which is just not cool and not epic. And I also kind of want it to be, I like the idea of doing it like voids, because I think that just for the fact that you don't really have to have anything pre-computed is nice. And the fact that you can have like a lot of really dynamic behaviors is also nice. So not 100% sure if this is what I'm going to be going with in the end, but this is what I'm going to try to do. I already spent some time a while ago trying to do this, and it did not work very well. But I think that's because I made a few key errors. And I made some assumptions that weren't quite right. Because when I was making it originally, I was giving it cases where that would have worked better for pathfinding, but I don't want the enemies to be that smart. See, the funny thing is, you can have the enemies be gods and know exactly where you are at all times, but that's not fun. If enemies can like no-scope you across the map, that you're not going to be enjoying yourself. And it's not going to be fair. Fair, in quotation marks, because fair is very subjective when you're trying to design AI, as I have been told by many people online, but it also just makes sense. So yeah, we'll see. I think that I'm just gonna get started in like in just a testing area. Entities, GUI, input, shared testing. Enemy AI. So we're just gonna completely start from scratch here, as if we were doing it in a new Unity project, and then we're gonna come up with a strategy for how we can integrate this if we get something that works nicely. I think we will use a player. Well, you know what? We don't even have to do a separate folder for this. We can just delete these guys. Yeah, because we don't need those. We don't need those. And I think having those are fine. Starting items, test area, managers onload. That's the start screen. We want this. Okay, cool. Oh, I forgot that it's kind of cold in my house, so I was like, oh, where's my blanket? And I'm like, oh, wait, I threw all that in the wash. Okay, so we need to get agents that try to follow the player, but also try to stay away from each other, and they also all have to know where each other are. So let's just make a C# script. And we're not going to do anything especially fancy. If we find something that we like, we'll adapt it. But I need to get something that works first. And you might be like, well, why are you not using like a library? I personally am not a fan of the Unity ecosystem. So, and just the way that people design packages and the way that it's built and everything. Like, I don't know. It just strikes me like every package I've ever used is poorly designed because Unity is a poorly designed game engine. So it just feels like the amount of jankiness just exponentially increases when I'm using a package, and if it's my own tools, my own tools might be janky, but at least I know how to fix them because they're my tools, right? And it just decreases technical debt, so that's just why I do it all myself. And also I just get to learn new things. So we need to have a static list, or here, Unity engine. Should we have like a hash map? We'd have to know where we are in the hash map. Yeah, we'd have to know where we are. Well, either way, we're gonna need to be using system.collections static hash map or hash table of agents. So this hash table cannot be used with type arguments. Really? That's a little weird. Maybe it's .generic. It's probably in .generic hash map, or it's hash set. There we go. That's what I want. So we have a hash set of agents, which basically means a unique set of agents. Void update agents dot. And we need to. Okay, so what if we remove this? Okay, so what we need to do is awake. We need to agents.add this, and then void destroy agents.add this. So the question, here's the funny thing. If we have a goblin and a bandit, right? Then we're probably going to want the goblin and the bandit to stay away from each other, right? But if we have bees, then we want the bees to do their own thing regardless of what the people on the ground are doing, because the bees don't have collision. So what I'm thinking is we have an enum for the group, or avoid group type, because that's something I know we're gonna need. Ground, aerial, and we also need to have object avoidance. Well, enemies, ground, aerial. Should aerial things that fly avoid objects, and what objects did they avoid? AI object type. Should it be AI object type? Ground, aerial object, or environment. Should that maybe be a collision layer based thing? Probably not. I don't think that's a good idea. So we'd have to register the ground with it? No. Because, well, So we could either have the awareness of the other agents be through collision, or we could have it be through a job that goes through all the agents and just checks the distance, which I think that would be cheaper, if I'm not mistaken. And if we want to have a lot of agents, then we probably want to just loop through all the agents and see what the distances are. So what we could do, so let's say every frame we, first of all, we have a target, serialized field transform target, which is going to be the player. And then we need to move towards the target, but then we need to actually calculate where we want to move. So we have all the agents. First thing we need to do is for the collision points agents, or rather, we need to use system.lenQ. Agents.select agent dot transform dot position minus transform dot position. So that way we're getting the and then we need to do that as a vector 2 because we don't care about the third dimension because this is a 3D game engine. Of course it is. Okay, so we have an agent transform position minus transform position. So that's the directional vector. Or, well, no, that's not even a vector. We're not even treating that as a vector. That's just straight up the distance. So then we do this. Dot distance, or magnitude, rather. The magnitude of the vector, the size, the length of it. So that's going to be the distance between each agent. So then we need to do serialize field float avoid radius. So then we need to actually, you know what? It's probably better if we do this. So we have all of the var agent deltas. So those are all the differences between the agent's position and our position, and then we need to check. We need to get the size of that distance. So we need to do var agent magnitudes agent deltas dot select agent dot magnitude. So now we have our agent magnitudes, and now we need to what do we need to do now? Well, now that we have our magnitudes and our deltas, we know what direction they're coming from. We know how close they are. Now we need to get our player delta, which is just going to be our rather, no, we should target delta. So that's that, and then we're also probably going to want to serialize field float target radius, and we're also probably going to want to do on gizmos, and then we're going to want to gizmos dot draw sphere, draw a wire sphere at the transform dot position, the avoid radius, gizmos dot color equals color dot red, and we'll do the same thing for this. Blue. And then we'll just copy this. And I know none of this seems like related to the task at hand, but it will all come back to be apparent what's going on, because I'm setting a lot of stuff up. Okay, so that makes, I think this all looks good. Now, what's the next thing we want to do? we need to combine all these vectors. But I want to see how they do that I want to see how Sebastian does it.
I think it's
Or is he gonna show any code?
All the points are just in a straight. A shorter segment called B. Now,
No, I think his videos are more of like an overview of everything. Voids.
So here's my.
You gonna show any code? No. No, you're not. Pff, Boyd's and Scratch? That's hilarious.
Hello everyone, in this video I'll be showing you how to create this awesome simulation using your boy. Okay. Wants to get a little bit closer to voids. It determines the angle of difference. So in this example, this boy do is to create. So you sum all of these. So I think something like this. So this is their center of mass. This void will apply a force onto our void in this direction. So basically, separation means every void wants to move away from all its neighbors within its perception radius. Okay, number 2 is
Move away. Okay, by a specific amount. We'd probably want to increase the force exponentially as you get closer, but like fall off. So, but we haven't even tried anything yet. Let's just do it linearly at a specific point. I'm not even really sure how to do this. This is where things like break down for me, because I'm good at like a lot of things. I'm not good at like procedural stuff. Okay, well, we may as well like move them towards the player first. So let's just do transform dot position. Or no, we need to apply a force. So we need to require component type of rigid body 2D. Great. And then we need to on awake. No, we're not going to serialize that. And then we are going to want to use this to dot force. And we're going to add a force mode 2D dot force, which means that it's going to be over time. And then we're going to get the var direction. None. Well, no. That's going to be our target delta. Dot normalized, and we're also going to need a speed. Float speed. There we go. Nice. And I also believe we need to do times time dot. So there we go. That's all we need to just move in the direction of the player, and then we need to add other forces on top of that. So let's just test it out first. So we need to add a sprite. Let's just add, what should our agent use? Let's just use that, because why not? Doesn't matter. And then we just throw the agent on here. We have 0 gravity, and we don't want to rotate him. And then the speed, Does not really matter. Let's delete that randomizer. Let's delete that guy. Player, agent, agent goes to player. Avoid radius. That's a little weird. Where's the GUI stuff? Oh, there it is. Nice. So the target radius should be a lot better than a lot bigger than the avoid radius, and the avoid radius should probably be that big. And then let's just copy and paste this a bunch of times. And we want them to we just want them to follow us, which is not happening because I did something wrong. Oh, because our hash set is null. So there we go. Now we have a hash set, and now they all know each other's positions. Okay. There we go. They are moving towards us, but they're very slow. So let's make them all a lot faster. Speed 100. How's that for speed? Okay, that's a little bit low on the drag, linear drag. Increase it a bunch. And then let's just... Alright, let's increase that a little bit too. Make it a little more snappy. No, they need to be a lot faster. No, that's way too much. How about that? And then the next thing we're going to do is separation. Okay, that looks good. Now we need to actually get them to go away from each other. So the naive approach is to just add all the vectors up. So let's just do the naive approach and see if that works. Okay. Var final new vector 2. So that's an empty direction. For delta in for each delta. I'm not gonna fuck with that right now. D dot magnitude. If magnitude is less than the avoid radius, then we are going to simply final D. And we are just going to do that, and then we are just going to multiply final dot normalized and see how that affects the way that it works. It looks like they're not moving because they're all on top of each other, but they have to move a little bit. So let's see if moving one of them does anything. It looks like it's completely overpowering their desire to kill me, which is obviously not beneficial. And they also just stay away from each other, which is just not a good idea. So what if we just do this over 2 and see how that works? No, that's not good. That's not good. This is not cool and not epic. You know what? It's probably a good idea if we... I wish the gizmos, I could just do them in here. Because that would be epic and awesome if I could do that. But yeah. Okay, so clearly the naive approach is not working. Draw line. from to transform dot position. We need to do that. Direction times 3.0 between vector 3 and vector 2. Okay, well, yeah, there we go. Please just let me draw a gizmo while not in the on draw gizmos thing. The worst. Bad game engine. Let's just do this for debugging, because I feel like having the direction is also going to be very helpful. Direction equals that. I messed something up, clearly. There we go. Just that variable name. I wonder if this is going to work. We'll just have to see. Does it show me the directions? I should probably do those in a different color and draw them at the last point. Okay. Okay, so I now have all the debugging stuff to get it to work nice, but it's not working nice.
Cohesion. Void.pde. P vector is basically a 1D array.
What the hell are you programming in, my boy? What is a PDE?
With velocity, and you can do many useful operations on them, like I don't know, adding, subtracting, multiplying, whatever. That's what make do for the constructor, I think. Voids. Okay, and then in setup, we're going to values that I determined beforehand. You might want to play around with it. Okay, and then we're going to declare all of our variables beforehand, and we're going to say 200, I think. Yeah, these are just values that I determined beforehand.
He shortens the variable names to make it impossible to read, true mathematician style.
Okay, and then what else do we need to do in the setup function? I think we just need to declare. I think this is how you do it. I don't know. And then in the methods, we're gonna. Okay, and that.
This guy's dumb. I don't like the way he's programming or making his tutorial. Just amazing. I've already watched this Boyd's paper. I'll just do the my man used this as his reference? The fuck? No. Pseudocode. Small distance away from other objects. Okay. Interesting. Maybe I'm just dumb, but that looks really easy. Okay, so let's do it. It's not cohesion, it's I mean, I'm doing something similar here, but not the same math. Is less than that, then yeah, I think that's exactly what we want. Okay, well, I don't really... That looks kind of like exactly what I was doing, except a little bit different. What if we just do just the separation vector and we don't try and add anything in? Oh, that seemed to work just wonderfully. Oh, that's actually really cool. Look at how cool that is. Okay, let's get them to be not exactly on the same spot as each other. You know what? Let's actually do a spawner. Create C# script agent spawner. That's actually really cool how easy that was. Look at them, they're going away from each other. So now we have a separation, which is step number 1. Now we need to combine that with them running towards me, and then booyah, we have the foundation for what we're going to be doing, or implementing. Field, game object, agent, awake, instantiate, this field, radius, and then we do gizmos. All right, and then we do for the gizmos color yellow, gizmos draw sphere, transform position, radius, and then we for agents. Agent count to do for I equal to 0. I is less than agent count plus initiate agent oh boy, there are so many function overloads. Oh, you know what we could do? We don't even... Here's a better idea to that. What if we... Because they could be on the same position. But they need to move towards me anyway, so why am I doing an agent spawner? Why on earth would I be doing that when I can just make them move towards me? Because that should be like a little bit different, but they all get executed on the same frame. If delta is equal to 0, vector2 dot 0, then delta equals new vector2 dum dot value over 100, and then we just do that twice to get them to randomly just spread out. Because if they're on the same position, then they need to move away no matter what. So we need to just add a random value. And then get separation vector plus target delta. Yeah, I think that's probably a good idea. And then they're not separating. That's just amazing. I don't actually see... Oh, you know what? I should probably have the scene open on the other screen because I'm not... Oh, wait. I just turn on the gizmos. So it's literally just that. It's not even... What if we just remove this? What happens then? Come on. Do something interesting. Yeah, you're doing nothing. Okay, wow, that's very cool. Because I know they would separate. This is embarrassingly bad, actually. Because I know this is getting run every update frame, so... What does the delta look like? It's obviously going to be 0, but it shouldn't be 0. Wait, is it not even getting run? What? That's not cool. Oh, it's because there aren't any other agents, because I deleted them all. I'm so smart. And then we need to add target delta back. Because, wow, I cannot even believe that I did that to myself. I edited the code without actually looking at what was in the game. That's awesome. Oh, that actually looks pretty decent. I don't like how they're kind of staying in the same, like, formation. Because that's kind of gross. Oh, look at how strict it is. It's like they're forming into a hexagonal pattern. That's so cool. Except that's not what I want them to do. I think that's just because the way that they move is very similar. So let's make one faster than the other ones. By like a lot. Let's just see what that does. No, it's still... They still clump up in that formation because the urge to flee is less than the urge to attack me, which is obviously not good. Dot normalized, and then we need to do this, dot normalized, and then what we need to do is we need to give this a weight of divided by 2. Or, you know what, let's just do multiplied by 0.75 f. And let's see how that does. Oh, look at that. That's so much better. Ooh. It's pretty decent. They're still getting pretty close to each other. I think that we should increase the weight as it gets closer. So, let's do something like, if this minus equal to delta times delta dot magnitude, and let's do a void radius minus that, and then let's do this over a void radius. Wait, and there we go. So that's the first way we can do the weight, is it gets much more forceful at the closer you get. So that way it's still like will make the voids want to stay away from each other, but it's also a matter of like we need it. I don't know. It's just a matter of like we need the voids to stay away from each other if they get closer to each other. Oh, that's so much more dynamic. Look at that. That's perfect. I think we should make it like 0.95 for the... Actually, let's make it stronger. Well, I don't know. It depends. I guess the weight depends on how close it is to the player. Oh, but this is like so cool. I'm very impressed with how well this works. You know, if you give it enough time, they will continue to get close to you. But you know what I want to do? I'm just not going to give either of them a weight. I'm going to make the separation equal to it and see what happens. The desire to separate equal to the desire to be near me. And it seems that it keeps them to stay away from each other pretty well. Let's make the cohesion factor for all of them. Avoid radius, let's make that like 1.95. Oh, look at that. They have to, they space out way more. Let's do like 0.6 because that's like way too big. Ooh, look at that. Also, I haven't had music playing this whole time. Okay, that was surprisingly easy to implement. So we can get them to stay away from each other. Now, can we get them to stay away from objects? The question is, we need to use like Unity's collision system for that. So let's see what we can do in that kind of area. Let's just not worry about agent deltas. It's not relevant. Okay, so we are gonna want, now that we have that implemented, which we can use this quite easily with a bunch of stuff. And I can make this like a static method pretty easily. That's nice. Okay. So now we're going to want something along the lines of object avoidance. So we're going to do a physics 2D raycast, and we're going to get a circle of vectors. I forget how to do that. No. Rotation 2-direction vector. I forget how to do this. Oh, you can just do a quaternion. Quaternion dot Euler. Then we do 0, 0, z of like 10. So we're gonna do this. Okay, so those are in degrees, so it's 360 times I over amount var plot. Vector 2.4. You can't do that? Why not? Vector 3. No. That's sad. Oh, look at that. Angle axis, float angle. And then the axis is... Oh, this is not working. This is just not working. I hate this part of Unity.
So you've got a vector. How do you do that, you ask? One of the ways would be to use quaternion angle axis method. It requires you to provide two pieces of information. The rotation axis, which is nothing more than and the actual rotation degrees around, is to multiply the received quaternion by vector we want to rotate. Let's have a look at a very useful example. We'll rotate a source vector by a random angle within a given range. And then
Is this like a recent thing? You can't multiply those two. What the fuck are you talking about? I mean, this is the new Unity UI, so I'm assuming this might be a new thing.
Together with the range and the source vector will be drawn using gizmos. Let's create a private method and call it rotate. The angle will be at max half of the from either left quaternion find angle axis, to which I pass the random rotation angle, and now we have to find the rotation should be happening around the z-axis. We multiply the result of tested using the inspector. And voila, everything works as expected. If you enjoyed this tutorial, don't forget.
That's just not a thing. I think I would have to upgrade the Unity project to get that. That's actually kind of annoying. Oh my god, everyone is saying that. How recent is this? When did they leave this comment? 2021. Okay, clearly, what Unity version am I on? 2020. That's why. 2020. No. That's in 2017. This is killing me. How did I do this last time? I'm such an idiot. My God. Let me just copy this and watch there be errors. What? No. Okay. Tell me how... What? I'm not using a different operator. It's the same operator. What the What? This is unacceptable. What? Only in that order? What? Are you serious? It's order specific? Why? That doesn't make any sense. Bro, I am furious about that. That is so unintuitive and horrible and awful. Impressive. Let's just double check that this works. Let's just check this works. Let's also just delete this method. Really quick like. Okay. Okay, let's see if that works. Let's see how well that works. Okay, they're all pointing straight up, so it's not being rotated around the correct axis. So I've got to try the y-axis now. Nope. What about the x-axis? Come on, that's gotta be it. Okay, I'm clearly doing something wrong. Let's log the quaternion. That's wrong. Amount. Oh, it's gonna return an int. Oh, it's 360 over I over amount. Divide by 0 exception. That's awesome. Plus 1. Come on, come on, do it. Do the thing. That doesn't make any sense. It's never 0. The hell? Why? Bro, this is not okay. I'm like, this is like war crimes, bro. I amount. I over amount. Just the fact that I have to put it in a tuple for debug.log to be happy makes me angry. That's not okay. That's not okay. I'm adding 1 to I. I is 0. If 0 divided by blah is blah, then adding 1 should make it work. 0, 10, 0. That doesn't make any sense. Why? God, why? Why must you pain me? I'm not even doing the thing that you're saying I'm doing. This is like so absurdly dumb. and idiotic. Amount 1 over 10. Oh wait, it's order of operations. I am so incredibly stupid. That is a new low. That is a new low. That is a new low. It has to be something related to order of operations. No, it's not. One over 10 is a tenth. It's 0.1. It's not 0. Oh, it's because it's int division. Wow, that is also a new low. So let's just add a float to everything here. Like, God, can you imagine the gall? God, C# is like a fucking bane on my existence. Sheesh. Okay, now we have something that more or less resembles what I thought we would get. Now we need to var rot. Just gets us the actual rotation. And we need to do a Euler thing. I'm sorry, this is taking so long. I'm just dumb and I haven't done this in a long time. I guess that could be an excuse. Come on. I'm pretty sure it's the z-axis. Oh, shit. Why is the game crashing? Alright, that's almost what I want. It's increasing in severity every single time. There we go. Fixed it. My maths were slightly wrong. The fuck? Excuse me. What the hell? Excuse me? Okay, so what if it's just not that? No, obviously not. Debug log. Come on, please just give me a break. I'm just trying to do this simple thing. 1.1. Oh, it's 10. What? How do I get this to be like 1 over? Oh no, it's vector. I need to flip it. It needs to be like vectors. It needs to be that over vectors dot length. That was my bad. Another math mistake because I'm tired and dumb. There we go. That is what we want right there. That is it. There we go. Now we can have an even distribution of rays that we cast into physics objects. So let's go back into the code. Now that I have this, we do not need that. Well, no, let's just keep it because why not? Okay. So now we need to do a vector 2. Um, so this is our collisions. Excuse me. Oh, we want this to be not 2 array. Collider distance. Dot where. So we only want to do that where the collider is not null. Oh, come on. Seriously? You can't have shit in Detroit. God damn. Just die already. I don't care. Just die. Microsoft Visual Studio is awful. Microsoft Visual Studio is awful. Microsoft Visual Studio is awful. Yuck, 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 yuck. Okay. Minus the right point. Okay, so we have all of the rays that collided, and then we also have all the directional vectors of those rays non-normalized. So then we can do, based on that, we can do the same thing here, except different. Um, none of those are from me, so I don't even need to check that. And then we already have the delta. If it's, the delta is 0. We would have to be, like, inside of some shit, so that doesn't matter. We'll keep that. V dot magnitude V. So it's the same shit. And let's just see how that does. So now we need to do, actually we need to do a layer mask for the raycast. So it needs to be, is this. No, that's not what I want. Not what I wanted. Not what I wanted. I guess I'm just gonna have to get the layer mask here. Ugh. The worst shit ever. Oh, you have to specify the distance. Okay. There we go. That's all I had to do. Ugh. Okay. Now that that's finally done, let us see what we can get up to. Just get rid of all that. Okay. We need to avoid default. Will it work? No, they don't avoid it. Let's actually give all the agents a collider. Because if they run into it, we're doing something wrong. Oh shit. Jesus Christ. They are annoying when they have colliders. What layer are these guys on? Let's put them on enemy collider so they actually collide with the right stuff. Because then they'll collide with the ground. That looks promising. But they still get caught on that thing, which is not good. We need them to have object avoidance. Yeah, see, they all get caught up on each other. let's debug the physics avoidance. It does kind of jump around a little bit. I'm not happy about that. Now, what if we have two of these guys? Let's do... Let's just copy all this code into here and debug why this isn't working. I feel like we're going in a good direction here. The weight needs to be 1 over that. The weight is completely wrong. It should be much larger when it's closer. Okay, so what we need to actually do is normalize all of these. So what we need to do, we need to do v dot magnitude v dot nor times v magnitude, which I think might actually help us with the other function. So instead of doing this, we could do dot normalize times avoid radius minus delta dot magnitude. That doesn't seem to be working as well as I thought it would. Let's just do it without the weight. What does it look like without the weight? Okay. Okay. Should be getting bigger when it's getting closer. That's not what I want. Should be getting bigger. Oh wait, that's because I haven't done this thing. Wow, I am absurdly smart. I think that's what we're looking for. It looks like they're avoiding it a little bit, but not nearly enough. I'm gonna multiply the physics avoidance by 2. And see how that goes, because we need it to be stronger. We need it to be stronger than the other forces. Okay, then let's just do physics avoidance then. I mean, I wish we could do the other thing like we did for physics avoidance, but it turns out that physics objects can be a variety of different shapes, and we can't just describe it with points. Just adding the draw line back for the direction, because I gave it up for some reason. Oh, that's perfect. That's exactly what we want. And let's do... So I'm just going to add them all together with the same weight, and hopefully it just freaking works, because that would be amazing. Oh, dude, this is so cool. It's a little freaky. It's pretty decent. They actually get around objects now, which is perfect. I think we need to turn the target stuff up. They're not following the target quite as closely as I'd like them to. Oh, shit. I haven't been looking at my YouTube chat. That's my fault. Go physics avoidance. Yeah, that's what I'm talking about, man. Check it out. They're actually like avoiding it. Oh, look at that. Dude, they're following me and they're getting around the thing. These guys are getting stuck. That's not good. Okay, it looks like I made the strength for the physics avoidance a little bit too high. Or I made the player stuff a little bit too high. Separation, and I think physics avoidance should be multiplied by like 1.2. Alright. Delta magnitude! Dude, do your dishes when you're done, son? Yeah, I will. Yeah, they're a bit messy. I have to go do the laundry in a bit too. Come on, boys. Avoid the stupid, the thing. Oh, they're getting stuck still. I mean, they sort of know what to do. But this is a little bit not cool. I mean, I think they're all, like, stuck on each other. I think that might just because of how, like... You know, I need to make them separate a little bit more. Uh-oh. Shit. Well, I was talking about doing the dishes. It looks like I have to do them right now. Alright. Jeez. I just completely tangled myself up. That horrible, horrible. But I think we're on the right path. I think it's going to need some balancing. What games should you get on Steam? I don't know, man. There's a lot of good games on Steam. You and me can talk about it later if you want. Oh, I need to go do the dishes and other stuff. But I do want to finish this. What time is it? Oh, it's 9:40. Damn. I feel pretty good about what we accomplished today. We got physics avoidance figured out. The separation between enemies, but still following the player, works really well. I'm really happy with that. But yeah, combining all three is going to be kind of difficult. But I feel like we're on the right path. And if we can get all those three things working really well, then I think it's pretty simple. Oh wait, you know what we can do? We don't have to normalize the Okay, well, I need to go do the dishes. I'll be right back. I want to finish this up. So I'll go do that, and then I'll come back, and then I'll try one or two things I just had an idea about. Alright, so one idea that I just had. There's something I want to try. Which is, instead of normalizing the physics avoidance, we just we just use it raw. Which, it's going to scale up the closer you get. So I'm thinking that might be better. Alright, let's see if this actually works, because that would be awesome if it did. Oh, look at that. Yo, it actually sort of works now. It's doing some weird stuff, but it's closer. You know what, I'm thinking we actually multiply that by 2, because that actually that's a little bit better. We need to make the target delta stuff not as important. Look at that. He got around. He was right behind it, but he got around it. They're not super smart, but they're smart enough. I don't like... They're still huddling up a little bit too much. I think I need to... To fix that, I need to do the avoid radius, make it a little bit bigger. So that their instinct to stay together is not quite as strong. Oh, that's a little too much. 0.8. Ooh. Oh, that. I think that's it. Look at that. Oh yeah, that is it right there, boys. That is it, ladies and gentlemen. I think that is what I want a horde to look like. Yeah, I know. It's looking really good. It's looking a hell of a lot better than what I had last time I tried to do this exact same thing. Whew. And I think doing an approach where instead of, like, testing random garbage, where I actually have them, like, follow the player, I think that's, like, really good. Let me remove the gizmos to see how it, like, really looks. This is really good. I'm actually really happy with this. So what I want to do now is I want to actually apply this to the enemies. Now, the problem with just doing that off the hook is this is like spaghetti code. Like, I literally just spaghettified this out to get it to work, and this is just not what we're going to be using, obviously. Like, it's just you know, just everywhere, you know, just not actually like what we need. So I'm going to get a drink, and what we're probably going to do is clean this up, separate it into little functions, and see what I can do to make this work better. I think a good thing. I wonder if you can physics 2D raycast from anywhere. Oh yeah, you can, from any file. That's actually really good, because then this function doesn't have to live inside of inside of a mono behavior. That's actually really nice. Okay, let me get a drink, and then we're going to separate this out and try and use it on some actual enemies, since this is already looking so good. Vector! Alright. So this is a class with our helpers. These three things are like the things that we use, that we're going to be using. These three methods right here. So get circular vector. Oh yeah, we need to make these all public static. Okay. Int ray density. So essentially what we do, okay, let me just do an overview of what we have working right now. So with this function, let me actually just summarize this. Gets a collection of vectors that out from the origin in a circle with the closeness of the vectors is determine how many vectors compose the circle is determined ray density. Vectors. Dog's barking right now. So there we go. That's a good description of what this function actually does. And then this, if I do, I don't know if I should be spending time doing doc strings right now. I'll leave it, but that's not a smart thing to spend time on right now. I'll do that later when I've fully, like, the system is done. So we want to replace all the transform positions with that. So we want to do vector 3. And this is just an unnecessary conversion right here. Float, avoid, ds. There we go, and then we need an avoid mask. So basically this function, after I get the avoid mask added. So basically what this does is it takes, let's walk through what this one does. So this one is the physics avoidance, obviously. So we get this function takes in a bunch of stuff and returns a direction that moves away from wherever the physics objects are. So to actually detect where the physics objects are, we get the player's position and we do raycasts out in a circle from that position, and we detect if those raycasts hit any physics objects. If they do, so first of all, we do those raycasts, right, for all those different directions. We get a circular thing of vectors which point out in different directions and everything. And then we filter out the ones that didn't collide with anything, because we don't care if you didn't collide with anything. If you did collide with something, we are going to get the difference of where we are to where the ray hit. So that way there's a vector out to where it collided at. And then we basically just combine all those together, and the closer the point of where we collided with is, the stronger the urge to get away, which is what this is. So we normalize it, and then this is basically what makes it so that the closer we get, the stronger the avoidance is this part right here. And then this avoid radius is just the radius before we start like going away from stuff. And I think that's pretty much it. I'll write a doc string for this later, but this function looks nice and tidy. So then we have agents. Let's just do a transform or a vector 3 array or a vector 2 array agents. Oh, okay. It needs to be like a game object. Oh, it doesn't even need to be a game object. It needs to be like a class. T, where T is a class. Or T is a class and is a mono behavior. Or no. It needs, oh shit. Okay, we're gonna have to like start specifying this to be able to actually do it. So the problem here is that we need to do all, oh wait, we don't actually need this condition. The reason that condition was here and why it was causing trouble, we basically need to check everything that isn't us for the avoidance of other people around us. But that doesn't matter if we just pass in everything that isn't us from the get-go. So we can just do this, and then we don't do a.transform.position. Agents positions. To be, and then we need to do world position here. And then let's also just make that a vector 2 for convenience's sake. We also delta equals v minus world position. And then if the problem is that if we're right on top of each other, if there are two enemies right on top of each other, then we have to add in a random value because we need them to separate even if they're right on top of each other. There we go. And then this is also just the weighting. The weighting is done differently. I think we might want to do the weighting the same as up here. Well, we have a different, like, functional thing here. You know, we'll just copy this, actually. And I think we need to swap this. And now that we have all these abstracted away, So now, what the good thing about what I just did is now that we can use these functions in any class. So what we would do here is we would do agent helpers dot physics avoidance, and then we can use it on any enemy. So we have the ray density, world position, transform dot position. Avoid radius is the avoid radius, and then the avoid mask is the avoid mask. So that's cool. That's done. And then we do agent helpers dot get separation vector, which is going to do. So we need to get the agent position. So it's agents dot select agent, and we are going to turn that agent into their position. Agent dot transform dot position, and then we need to make a vector2 out of that, and then we need to dot where agent So where every agent is not us, and we're going to turn that into a vector2 of things, or we're just going to turn their positions into vector2s. We're going to turn this list of agents into their positions, basically. That's all we're doing. And then the world position, transform dot position, and then the avoid radius. And that's it. There we go. We just re-implemented everything. Oh, we have a type argument here. We don't need that. Great. What now? IEnumerable is not an array, so we need to do dot to array. Look at that. There we go. I just took out all of that functionality and put it in a different place. I took all the functionality and put it over there. So now we can use it anywhere, pretty much. And it's not tied to one specific class, which is great. So we can use this with anything, and it should work. And it should be basically the same. If it's not, we're going to fix the bugs. Okay, clearly there are some bugs. I think it might be with how I messed with this. How did I do this before? Let's just copy that math and not mess with it this time. Pretty good progress we're making here, but still not sure how this is actually going to pan out when I start introducing it onto actual enemies. That's not right. They're not avoiding each other like they should be. Whopper, 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 whopper. Okay. Let's just debug the physics avoidance for now. Let's see if they're actually, like, avoiding the physics properly. And once we've confirmed that it, like, works the same, and we've separated it out, we can then, actually introduce it to the enemies, because... yeah. The physics avoidance seems to be working correctly. That's so cool. Every time I watch it, it's awesome. Isn't that so cool? Alright, well, that's confirmed to be the thing that's okay, so it has to be the other one, the separation shit. Yeah, they do be moving. I'm quite proud that they're moving in the way that they are. Okay, so we're gonna do the get separation vector. I'm not exactly sure what the problem with the separation shit is. It's probably something like really easy. Is it normalized? It is normalized. I think I may have figured out what the problem was. I may have figured out what the problem is, and I may be kind of dumb, but we'll see. There we go. I just flipped the signs of a thing that shouldn't be flipped. Nice. Now we can combine all of them, and then it should just work literally the same. Two plus that. Is that normalized? No, it's not. Good. Okay. Okay. Fingers crossed. Come on, buddy. There we go. Look at that. Ooh, look at them boys move. Look at them boys move. Look at them move. Look at them move. Look at them move. Okay, well now that we have all that working, we are gonna try to do this with just the bandit for now. I also need to like separate all of those things out. And then I'm going to commit this, and then we're going to try and introduce it to stuff. Okay, so we have our agent helpers. These are the actual, like, things that are helpful to us. Gen using system.linq. I believe that is it. There we go. We now have agent helpers that are available to us anywhere in the project. And now we can actually start doing some interesting stuff. So, let's start with the, who do we want to start with? Okay, so I made this system. It works pretty decently. Let's look at all the enemies that we have. So, bandit, most simple attack pattern, just rushing the player and stabbing them. That's probably what we're going to use. We'll chase at the player until they're in range, and then try to dash through the other side of the player. That is a completely different behavior. Slimes will do their best to stay on top of the player to slow them down, block their shots. That seems pretty reasonable. They apply slowness, and we probably also want to make the slimes fast. Rangers try to keep their distance from the player while firing arrows at them if the player gets too far away. Okay, this is going to be a completely different steering behavior. Goblins are exactly like bandits, except that they will try to run away if they reach half health. So, I think we should probably aim to do the bandit first. So the bandits, goblins, and slimes all benefit from what we just did. Rangers benefit too. Wasps benefit too, and wolves benefit too. Most of them benefit from the physics and... I mean, all of them benefit from what we just did, but like... some of them will require custom stuff, and I think the bandit will literally just require what we just did, plus, like, almost nothing, I think. Yeah, I don't think there's anything else we would need with the bandit. So, let's try it out. Wait, one thing I want to try actually before we do that is we're not normalizing the entirety of this. So I am going to try that. Var separation equals this. It's separation plus physics plus that. There we go, nice. So, I just want to see everything normalized real quick before we move on. Actually, we don't have any agents. I deleted them all. That is a problem. Why did I delete all those agents? I have to do all this stuff again to see what I was doing. Sprite renderer. No, that's not what I want. Sprite renderer. Then we get a bleed, and then we do a agent. We do 0 on the gravity. Transform for that is going to be that. Avoid radius, speed 400, ray density is probably going to be like, let's do like 25, or let's do just 36. Target radius, that's good, that's good. We avoid default, and then we can just add a box collider to that, make this an enemy collider, and then copy and paste a bunch of these guys, and then I think that's it. So I want to see what it looks like when they're moving a constant speed. Oh, they should not be rotating. That is not good. That is bad. Because that throws out of whack everything that we're doing. What the I told them to freeze the rotation. Why are you not? Oh, because I only did it for one of them. That's my bad. My bad. Alright. Okay, let's see what it's actually supposed to look like. Okay, let's make their avoidance radius a little bit bigger. And then let's do like 250 for the speed, because they're moving a little bit quickly. Oh wait, that's because their drag isn't that big. They need to have like, because currently they have no linear drag, so it's like they're skating on ice. Let's do like 3, and then let's go back up to 400. Because the normalization of all of them makes a big impact. Because you know how they were like slowing down as they got closer to you? This basically makes it so that they don't do that. Oh, that is way too big of a avoidance radius. Oh, look at these guys. They're chasing me. They're chasing me down. And they don't slow down for nothing. They move at the same speed, no matter what. And look at them, they're grouped up. I don't like how they're, like, grouped up like that. That's actually bad. Let's not normalize the separation vector. See what that does. I'm not happy with that. Let's multiply the separation by like 3, because they are not regarding that as much as I would like them to. It is crazy how difficult it is to balance this. But I feel like it's on its way to doing good. There we go, look at that. That's pretty decent. Yeah, I think this is good to add to the bandit now, so let's do it. Oh boy. Oh my god, this is gonna be like so annoying and difficult. Okay, let's commit our results before we do that, because we have made a shit ton of changes. Knockback adjustments. This is not the branch we want to be on. Let's stash our changes. Discard that. Stash all. Come on, stash them. There we go. Now we go to main. We fetch. Then we delete that branch. Actually, wait. Is there stuff on here? No, there isn't. Okay, delete that branch. Actually, let's just make it a... Oh. Those stash changes are only on there. What if I change to main? Delete. Wait, hasn't knockback adjustments been, like, merged? Yeah, it's been merged. Okay, well then I'll delete it on there too. New branch, enemy AI. There we go. Feet, enemy AI, tech, demo in test area. There we go. So that synced all my changes to the cloud. Let's just make a new pull request for that. Enemy AI. And this is what we're going to be working on. Okay. What time is it? It's 10:18. How long have I been live? I've been live for 2.5 hours. Well, I mean, I'm tired. I think I did pretty good for today. I might just come back tomorrow and finish it up then. Because I'm tired. I had to do my regular job today. And I feel pretty satisfied with what I was able to accomplish in this short time. So, hopefully you will forgive me, because I am probably going to get off now. So, yeah, thanks for tuning in. Pretty happy about what I was able to get done with that tech demo. Some pretty good enemy movement is brewing, I would say. And I definitely feel like we're on the path to getting some very interesting enemy fights. Dude, this game is going to be so good. I'm excited. It's going to be great. All right, see you guys later. Appreciate you stopping by. Go join the Discord, get notified, hit the bell, subscribe, do all these things to stay in touch, see what I'm working on. And yeah, I'm pretty happy about where we're moving. Yeah, I think that's going to be it for me. Bye, guys.